Welcome in this session of Basic Mechanical Engineering. Now we will discuss the basic cycle in which the refrigerator operates in order to maintain the body at a temperature lower than the temperature of the surroundings. In the previous lecture, I have already talked that the refrigerator operates in a cycle. It is a cyclic device. It operates in a thermodynamic cycle. That's why I've used the symbol of cycle. So refrigerator operates in a thermodynamic cycle. The same thermodynamic cycle I'm going to discuss over here. One of the basic thermodynamic cycle in which a refrigerator operates is known as vapor compression refrigeration cycle or vapor compression refrigeration system, denoted by VCRS. The basic thermodynamic cycle in which a refrigerator operates is known as vapor compression refrigeration cycle or vapor compression refrigeration system. Let's observe the cycle, the important components of the cycle one by one. The refrigerator is fitted with these four important components. I think it is very easy, you all know it. The refrigerator is fitted with a compressor. There is a compressor inside the refrigerator. Another important component is the condenser, expansion device, and evaporator. These are the four important components of that cycle: compressor, condenser, expansion device, and evaporator. This is the pipeline connecting these all the components. This is the hoses connecting all the components. So this is a cycle in which the refrigerator operates. The compressor is filled with, or this cycle is filled with suitable refrigerant. The refrigerator contains a suitable refrigerant. Earlier we used to use CFCs and HCFCs as refrigerant. CFCs like R12, R11. But since they have been phased out due to their ozone layer depleting potential, now we are using some hydrofluorocarbons or HFCs as a refrigerant, like R32, R125, etc. There are some inorganic refrigerants as well, like ammonia, CO2, H2O, etc. So this cycle carries a suitable refrigerant, which may be R12, R11, or R32. Now understand how the refrigerant operates in the cycle and maintains the body at a low temperature. Please observe carefully. Let me start from this point. I think you have visualized the cycle. Let me start from this point. Let the refrigerant at the exit of the evaporator. The refrigerant is in vapor form. Over here, the refrigerant is in vapor form, dry and saturated vapor form. The refrigerant at this point 1 is in the vapor form. The refrigerant at the exit of the evaporator is in the vapor form. Now this compressor is there. Through this compressor, the suction of the refrigerant takes place. The compressor sucks the refrigerant inside. So the suction of the refrigerant takes place, vapor refrigerant takes place inside the compressor. The compressor is a device that compresses the refrigerant. Compressor compresses the refrigerant to a very high pressure and temperature. Inside compressor, the process which takes place is known as isentropic compression. Means the refrigerant is compressed to a very high pressure and temperature isentropically. Means the entropy of the refrigerant will remain constant and the refrigerant is compressed from pressure and temperature P1 T1 to pressure and temperature P2 T2. Now through compressor, the refrigerant is delivered to condenser. And observe, the refrigerant is still in the vapor form. I'm not using the words like superheated vapor or to confuse you. You are the students of basic mechanical engineering, therefore I'm using the word vapor only. Therefore, the refrigerant which was in vapor form at the exit of evaporator has been compressed to a very high pressure and temperature, but it remains in the vapor form. Now the refrigerant enters the condenser. Inside the condenser, the process of condensation takes place. What is the meaning of condensation? Condensation is nothing but it is a phase transformation wherein the vapor is converted into liquid. And how the vapor is converted into the liquid? By rejecting the latent heat. So inside the condenser, the process of condensation takes place. The vapor is converted into the liquid by rejecting the latent heat. So here inside the condenser, the refrigerant rejects heat into the surroundings. Again, I am repeating, inside condenser, the process of condensation takes place. The vapor refrigerant at the entry to the condenser is converted into the liquid refrigerant by removing heat into the surroundings, and this process of condensation takes place at constant pressure. The process of condensation takes place at constant pressure. The vapor refrigerant is converted into the liquid refrigerant by rejecting heat into the surroundings. Now, the next process from 3 to 4, the refrigerant now flows, this liquid refrigerant flows through this expansion device. Inside the expansion device, the expansion of the word expansion means a reduction in the pressure. So inside expansion device, the expansion of the liquid refrigerant takes place. The expansion of the liquid refrigerant takes place. During expansion, some of the liquid is converted into vapor. Some of the liquid is converted to vapor. So mostly at this point 4, the refrigerant is in liquid form. Most of the refrigerant is in liquid form with partial vapor. Again, I am repeating the process 3 to 4 that takes place inside the expansion device. Here the liquid refrigerant expands inside this expansion device to a very low pressure and very low temperature. Means at point 4, the temperature of the order of minus 25 to minus 30 degrees centigrade. Again observe, the temperature of the order of minus 25 degrees centigrade is achieved at that point 4, the temperature of the refrigerant. Please note. So during expansion, the pressure as well as the temperature of the refrigerant falls. The temperature of the refrigerant reaches up to minus 25 degrees centigrade. Now the refrigerant is ready to enter the evaporator. The body has been placed over here. The body has been placed over here. Now inside the evaporator, the refrigerant evaporates. Means inside the evaporator, the refrigerant has to convert from liquid to vapor phase. For converting the liquid to vapor phase, a process, a very important process, which is known as evaporation, takes place. In this evaporator, the liquid refrigerant converts from liquid to vapor by extracting the latent heat from the body itself, from the body which we want to cool. Again, observe carefully. Inside the evaporator, very important process of phase transformation takes place, which is known as evaporation, wherein the liquid refrigerant is converted into the vapor refrigerant. Since the liquid has to be converted into the vapor, the liquid requires some of the latent heat. And from where this latent heat is absorbed? Inside evaporator, the latent heat is supplied from the body. The latent heat to the refrigerant is supplied from the body. The refrigerant converts from liquid to vapor inside the evaporator. Heat is removed from the body and hence the body gets cooled down. Please, this point is the very important point. The refrigerant converts from liquid to vapor inside the evaporator by extracting latent heat from the body. Since the heat has been extracted from the body gets cooled down and hence the cooling effect is produced. Therefore, the evaporator is that section of the refrigerator where the cooling effect is produced. Okay, and then the cycle remains continue. Again, the refrigerant is in vapor form. It goes through compressor, condenser, expansion and evaporator. This is the cycle. This is the important cycle. If you compare this diagram, this cycle, observe, this cycle has been replaced by these 4 components. This cycle is a combination of these 4 processes. So this is the vapor compression cycle. Let me again tell you, there are 4 processes. 1 to 2 is the isentropic compression. 1 to 2 is the isentropic compression. I have written down isentropic compression. 2 to 3 process is the constant pressure heat rejection, which takes place inside the condenser. Process 3 to 4 is isenthalpic expansion. During process 3 to 4, the expansion of the refrigerant takes place, but the enthalpy of the refrigerant remains constant. You need not to be worried about these processes. You have to simply remember these processes as you are the students of basic mechanical engineering. Now, constant process 4 to 1 is again a constant pressure heat addition, where heat is added to the refrigerant from the body and the body gets cooled down. So I have written down the entire theory. You need to go through this theory as well.